Hello, and welcome back to the lecture series for Introduction to the Art of Programming Using Scala. As we close out the chapter on functions, I'd like to just give you a few other examples. I'm going to use two different examples that are in many ways distinct from the things that we've done before. The first one is unit conversions. Now, unit conversions are a very common example of using functions in programming, things like doing a Fahrenheit to Celsius or Celsius to Fahrenheit conversion. But I want to throw a little extra challenge into this, and I want to do fluid volume conversions using English measure, so ounces, cups, pints, quarts, and gallons. Having multiple options there makes things a little bit more interesting for writing a function. And I want to write one function that can potentially do all of those by having the user pass in some arguments. The other one is an example of just splitting up a name from standard format to last name first format, just as something that doesn't use numbers anywhere, to demonstrate how we can do things with strings instead. So let's start with our first one. Let's edit this fluid conversion file. And once again, I don't do this much in the videos because the videos are supposed to remain short, but you should probably, if you're writing these things, get in the habit of put some comments at the top. Okay, so what I want here is I want to have, let's see, convert volume. Amount is, I don't know, I'll be flexible. I'll go with a double. Could go with ints. We could say that you're only allowed to use whole numbers, but in this case, I don't think there's a real good reason for putting that restriction on. Now, what we're also going to pass in here is the current units, which is a string. So they're going to pass in the string, OZ for ounces, cups, pints, quarts, or gallons. And then they're going to pass in a second string, which is desired units, also a string. And this is going to return to us a double. And now I'm having an issue here where this line has gotten long enough for word wrap. In that case, I am going to go ahead and hit enter after one of the arguments so that I can move to a whole new line, and I double indent so that it is offset from the rest of the code. These types of conventions, different people do things in different ways. You can decide what works for you, or perhaps your instructor has a specific requirement for you. If you're in a place of employment, a lot of times they will have style guides, but doing something to make it so that the code is readable for humans is a significant habit that you should get into. So the question now is, how are we going to do this? And I've posed this problem specifically because I think it does have a little bit of a challenge to it, in that the way that you do this conversion depends upon what the input units are and what the output units are. Okay, and I have 5 possibilities here: ounces, cups, pints, quarts, and gallons. And one way to write this function is to write all possible combinations of the two. So that would be 5, choose 2. You can work that out. There are 10, and that assumes we don't allow them to type in a silly one like converting cups to cups. It turns out that there are that you probably don't want to put that limitation, because there are times where someone doesn't want to do a conversion on one thing in something, and so you wind up calling the function and you're going from something to itself. So yeah, so then we have the problem that we have 5 things, and each one needs to be paired with the 5 other options, and lots of possibilities here. So that turns out writing that code, so I could say, well, if current units is ounces and desired units is cups, then whatever. It would actually be amount divided by 8 would be my answer. And then I'd have an else if, else if, else if, else if. There would be a lot of them, though. And so to avoid, we want to try to find a way to avoid going through that, especially because it turns out, what if I wanted to, I decided later, oops, we need to add tablespoons. Well, that now adds a 6th one, and the number of options that we have goes up in a combinatorial way. So your code will actually get significantly longer just by adding one more option. And I'd rather not have that happen. So how could we get away from that? Well, I can do the conversion in 2 steps. The first step I'm going to do is whatever the input units are, I'm going to convert it to ounces. Okay, so val amount in OZ equals, well, if current units is OZ, then it is just amount. Okay. Else, if current, whoops, I left off a close parentheses. That would have left us a nice error. If current units is cups, then I want to take amount times 8. So 1 cup is 8 ounces. Cups, pints, quarts, gallons, and the gallons will be we're just going to make that our default here. We could have something that works with an error message. We haven't learned enough to know kind of the proper way to do error messages, so I'm not going to do that here. Cups, pints, quarts, and then the last one is gallons. So pints, well, there are 2 pints in a 2 pints, or 2 cups in a pint. There are 2 pints in a quart, and there are 4 quarts in a gallon. Now, these numbers here are something that you might be tempted to work out and put in. So instead of having the multiplication, you could have 8 and 16 and 32 and 128. Now, for some of those, okay, the 16, people would probably figure out what's going on, but when they get down here to this 128, they'll be like, what the hell is that number? It becomes something of a magic number for them. And it turns out that the compiler here is actually going to see this string of constants and go, oh, that's a whole bunch of constant numbers. I'm just going to collapse them all together. And so it doesn't actually slow it down, and this is going to be more readable and more understandable, most likely, for the person who comes and looks at your code. So now I have whatever the input units was, I have the that in ounces. And now what I want to give back is the value in the desired units. Well, that requires another set of nested ifs. The thing to note here is, whereas if I had tried to do this in one thing, that my original approach where I said, well, if current units is something and desired units is another, those ifs depended on both. The way I'm writing this now, I have one string of ifs that depends only upon current units, and then I'm going to have another string of ifs that depends only on the desired units. So if desired units is equal to ounces, then this is amount in OZ. else. I left off that double quotes. Here this would be divided by 8. Pints, quarts, gallons. The gallons will be our default. And I'm actually going to put in some parentheses here. 8 times 2. 8 times 2 times 2 times 2 times 2 times 4. Note that I am, in both of these cases, I am using the if as an expression. I did not create a var anywhere that then gets set to a different value. I created one val, and my if up here gives back the value that I want stored in it. And this if down here just calculates the value that we want to return. So to make this a complete script, print line. How many units of fluid? Val remember in the earlier video I talked about the fact that this variable and this variable are not actually in any way necessarily associated with each other. They will become associated when I actually call convert volume. They might have the same name, they might not. If they happen to have the same name, it's just like two people named Bob. Doesn't mean they're the same person just because they share the same name. Print line. What units is it currently measured in? And it might be nice to print out the options. Okay. This is an interesting one here. So I said earlier that I like to break the lines so they don't hang over. What do I do here though? I can't put a new line in the middle of this, and it turns out that when it prints out it won't span more than a line, so it's not a problem. One way to do this would be to do something along these lines where I do a string concatenation, and I'll leave it like that. Once again, it's a style issue. You can decide what you want to do. They are both technically correct. Equals read line. I'll read 3 lines, or yank 3 lines. What units do you want? Print line, convert volume, from AMT, C unit, D unit. And if we come over here and we run this, let's see how many typos. Okay, managed to find all the typos as we were going through. How many units of fluid? I don't know. Let's say that I have 4 pints. And I want to know how many cups it is. And the answer should be 8. And it is. Okay. What if let's run it again, and I have 2 gallons, and I want to know how many ounces that is. It's 256. Okay, so you could play with this. I think this program is good, is a good illustration in the sense that it is reasonably significant. It's not a complete little toy problem, but it nicely throws together many of the different things that we have learned so far. So what about the other function that I mentioned. This is the name formatting. And what I want to write is a function that I'll call it last name first. So we're going to pass in a person's name in string as a string, and it is supposed to be just like the way you would normally type it in. First name, first name, last name, possibly first name, middle initial, last name. And I want it to give us back another string. Now it turns out that doing this really well is hard. And so we're going to ignore a few possibilities. For example, suffixes. You are not, the name that is passed in is not allowed to be a junior or a second, third, fourth, because that will totally mess us up. So we're expecting that it is in a normal format where the last complete word is the last name. And once again, there are situations where that's not the case, and we could make this function more elaborate, but that's not the goal here. I just want to demonstrate that we can do something that's reasonably simple in doing this. So how am I going to do this? Well, if I assume that format, so they have a simple last name that doesn't have any spaces in the middle of it, and really that's the significant part here, then I want to take and find the last place where there's a space in it. So I'm going to create a variable called space index. And I will make it equal to name dot last index of a space. Now you might remember that we saw when we were learning about, when we talked about some of the details of strings. Strings are objects, they have methods in them, and some of those methods include things like index of, where you can look for stuff, as well as last index of, where you can look at the last, find the location of the last occurrence of something. So this is going to give us back the last occurrence of a space. And what I want to do is I want to break the string into two pieces at that location. So the first name is going to be everything before that. And the question is, well, how do I get that? Well, if you had looked at the list of methods, one of them is called substring. And so that's what I'm going to call. Now substring takes a first argument, which is the first index of where you want to start taking characters. Indexes start at 0. The first name starts at the very beginning, so I'm going to pass in 0. And then the second thing you pass in is the index that is one beyond the last character you want. And in this case, the last character that I want is the thing right before the space. I don't want the space. I don't care about the space. Well, if I pass in space index, this gives me everything up to but not including the space. So the last name then should be everything after that. So I'm going to do space index plus 1. I don't want the space here either. I want to throw it away. And I could type in name.length here, but it turns out there's a shortened version of substring where if you're going to the end of the string, you can just pass it one argument. And now what I want to give you back is the last name plus a comma and a space plus the first name. So let's make this a full script. Print line is your full name, and val name equals read line. Now I'm going to do something here. I'm going to take that read line and I'm going to call a method on it called trim. And what trim does is it removes any leading or trailing spaces. Just in case your user, to be a jerk, types in, space, 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 their name, space, space, space. Well, if they type that in on the read line, and you look for the last index, well, it's going to be the absolute last character. And that's going to cause a problem here because then this function won't work. By trimming the input, we throw away any spaces they happen to insert at the beginning, any spaces they happen to insert at the end. If they put multiple spaces in the middle, we can't deal with that. But we can deal with the ones where they have multiple spaces at the beginning or the end. And then what I want to print out is last name first of name. So if we run this, let's go with the simple version, Mark Lewis, Lewis Mark. Looks like what we want. What if I say Mark C. Lewis? That works too. Just to check that the trim is doing what it's supposed to, space, space, Mark C. Lewis, space, space, space. That still works as well. Okay, so that is an example of a simple function that uses strings, just so that you can see how we can include that as well. And that's it for this video. We'll be moving on to the next chapter in the next video, and we will put together our conditionals and our functions to use something called recursion, which will allow us to do things many times. So see you then.